Hi, this is the second video for lesson 12.3 where we are continuing our conversation on box plots. There's no notes that you need to glue in. Today's video is just a continuation of me explaining why we want to use box plots in the world and what it actually shows about data. You were instructed to do two problems on page 883, so you need to do those first, and at the end of the video I actually will be going over those so you can follow along and make sure you did that correctly, or answer any questions that you might have had while you tried them first. So make sure you do that. So just to review, the box plots again have 5 different pieces that allow you to construct or draw the box plot. It's important to note that the box itself is talking about the interquartile range. And that is one thing that we like about using box plots. You can see easily what the center spread of the data looks like. And then the entire thing from whisker end to whisker end is the range. Box plots can look different. It doesn't have to be horizontal. They can be vertical as well. And you can also add in this piece about percentiles. So 50% of the data is in the boxes. That leaves 25% up here and 25% down here. So if you start at the bottom and go up, that would be the entire thing. So 100%. This is what we used in chapter 11, the lower limit or the lower boundary, and then if anything beyond that is the outlier. On the same end, on the top end, we have the 75%, and we're going to add the 1.5 times the interquartile range to get that upper boundary, and then you see the outlier is beyond. So this is just another way to show this vertically, and it has that upper limit and the lower limit so that we can establish if there are any outliers. This again goes to hints at the standard deviations that I mentioned before. You can see that the box plot here is dealing with the IQR range, and if you follow that down, it's on the high end. This is called the bell curve, and it looks like a bell. At 50% of students or of people surveyed should fall somewhere in this center area. That's been a pattern that we've noticed over time, which is why standard deviations have come into existence to kind of put a name around that pattern that we were seeing. On the low and the high end, you see it tapering off. Not as many people fall in this category, not as many people fall in this spot, but there is the 1.5 times the IQR to establish what that lower limit would be and what that upper limit would be. Anything beyond that is that outlier. Just wanted you to see how the box plot actually connects to what's called the bell curve and standard deviations, something that you'll get in your future math careers. Now I want to talk about the actual size of the boxes. That matters. Sometimes the box on the left is going to be the same size as the box on the right. That's important to note. Sometimes the whiskers are going to be different lengths. You can see this one's short and this one's long. The bottom two are something that you can do to compare. Say you wanted to take class averages, class A and class B. You could actually take the data of those class averages and create a box plot. And then you can compare the two classes. So in this case, the range of class B was greater. You can see that by the length of the box plot, and as compared to class A. Also, you see that the interquartile range is located lower from class A, and it's actually higher in class B. So you can definitely see very quickly which class on average performed better. I would say class B, because more of the data exists in the 70s and 80s versus just 80s and below. Again here, test 1 and test 2, you can see that this one has the same range. This one ends on either side at the same point, but the box themselves, the interquartile range, is bigger for test 1 than it is for test 2. What can we say about the spread of that data? The test 1, the data is more spread out. In test 2, the data is closer together. It's closer together. Here's a real 6th grade, real life example of box plots. Do you remember those 8-minute tests and that 3-minute test that you took? It's called Ames-Webb. Ames-Webb testing actually gets put into a system in the computer, and we can look up actually progress. And what you see here are a lot of different vertical box plots. And you can see the key over here. The box actually is the average. We want people or kids to fall in this green range. Blue means you're above average, red means below average. And the dot is actually the student's score as they took this exam. This was one of the math ones, and this is actually a student's information. You can see over here, falling a little bit below level, and here, but then they are approaching the green, and now they're in the green. And they pretty much stay in the green all the way through. This one is interesting. They go from the bottom down up a little bit more, and then they're still in the average range. Here, they're in the average range, then they pop up, and then they're still in the average range. And here they're in the average, they're above, and then they're above. Here there's average and above. So you can see this student struggled a little bit more with this test, but sometimes did good. And on this test, the computation, they were very solidly average, or sometimes above. So it's a way to track progress, and it shows where the student is in relationship to the entire population. We hope that the entire population is in the green, and we can track where they are accordingly using this visual in 6th grade. This is what we actually talk about when we talk about kids and their progress. Here it is, again, bigger, so you can see actually this is a different child and a different test. This was a reading test, so you can see this dot is in the green, even approaching the blue, then still on the blue, average, in the green, all the way through. So that's what we like to see. And this was, I believe, the 3-minute test that you took, and this was one student's, which will remain anonymous. So here is the first example you were supposed to try, page 883, number 1. First thing is to put them all in order. I've already done that. Now we need to find our 5 pieces, our 5 numbers. So the first one is going to be the minimum and the maximum. Just going to label it right on the numbers. You can chart it out separately on the side too. So now we're going to find the middle value. 3 matches, 4, and then we have 1 number in the center. That is our median. So we have an 88. Now we need to find Q1. So we're not going to use 88. We're going to now cross off. And we have 61 is Q1. The same thing on the other side will give us 97 for Q3. So we have all of our 5 pieces. Now we're going to put the dots on our box plot number line. I have this one here from our book. We're going to put a dot above 35, a dot above 61, and we do have to estimate a little bit. That's okay. Approximation. Then our median is 88, way over here. And I'm going to try to keep my dots in a line to make our box plot. And then 97 is Q3, and 100 is maximum. So we need to draw that vertical line through the median, Q3, and Q1. Then we're going to connect the top to make that rectangle and then connect the bottom. And then our final step is our whiskers. And we're done. Notice this one, we have a very small whisker over on the right and a very long whisker on the left. And our actual interquartile range is not even on both sides. You see that this box is a lot smaller than this. That means that the data is not distributed evenly. That's what that uneven box means. Let's head to the next example. In this example, we have a new set of numbers. They are in order, so we are set to find our 5 data points. So we have our minimum and our maximum. 174. Now we're going to find our middle value. So we have the max and min match. We have the second match, third, fourth, and now we are going to be having to find the middle of those two numbers. Review, if there's a larger spread and it's not just one number in the middle, we will have to add them up. And then we're going to have to divide by 2. This is an odd number, so I know it's not going to work out. Dividing by 2, we have a 1, another 1, we 3, and then we're left with 1/2. So our median is going to be 113 and a half. I'm going to go ahead and erase my work so I can draw my box plot. We have our median. Now we're going to find our Q1 and our Q3. We can use 105, so I'm going to check that off. And we are left with 95 being Q1. We're going to find the middle value of the upper half, and that is 162. We have all of our 5 numbers. Now it's time for our box plot. Now our scale here is every 10 is a hash mark. So 55 is going to be halfway between the first and second hash mark. Then we have 95, which again is halfway in between the 90 and the 100 hash mark. 113 we're going to have to estimate a little bit more. So it's going to be a little bit past this 110 hash mark. We have 162, again a little bit past the 160 hash mark. We have 174, which is somewhere close to the halfway in between 170 and 180. Here are our 5 dots. We're going to draw a vertical line through Q3, a vertical line through Q2, or the median, and Q1. Connect the top to make that rectangle, and connect the bottom, and then connect to make your whiskers. Again, notice the boxes in the interquartile range are not the same size. That simply means that the data is not distributed evenly, and our whiskers are not the same either. So that means that the data is not symmetrical from the median going on to the upper and the lower. It's not going to be the same on both sides. Tomorrow we will practice this more, and I will see you then.